going to be taken at the end of the year. I'm moving on. You've got access, even if you don't have access at home. If you get into a situation of you cannot get online at home, try to get on your phone, because you guys have fancier phones than I have. Oh, it won't let me upload your video from my phone. Okay, then go to the library at 8 o'clock and watch the video at 8 o'clock. But I can't do that. Then go at lunch. But I don't want to leave my friends. Then stay after school. Y'all got to do what you got to do. I got to do what I got to do. I got practice. Well, okay. You got to find some time that you're going to do this. Or either you're going to show up here in my face at 8:05, 8:10, and I'm going to help you. If you miss because of field trip, because of whatever, I'm moving on. I'm not slowing down. Okay? Did you figure out 6? Okay, cool. All right, so let's look at this word problem. Okay? 24. I'm going to come back and get 6 in just a minute. So you've got this plane. Here it is. And you've got this triangular-looking shape. And we're dealing with big distances. Okay? And you have to draw on what you remember from, bless you, geometry. It says a pilot is flying over a straight highway. He determines the angles of depression to 2 mileposts, 5 miles apart, to be 32 and 48 degrees as shown in the figure. Find the distance of the plane from point A. All right, that is part A. So from, all right, had to find for part A. Did you see where I put your hat? Okay. All right, here we go. B. Okay? We've got to find the distance from the plane to milepost A. And I'm going to call that side little b because it's across from angle B. Now, folks, you got to remember that if this is an angle of depression here, what other angle is 32 degrees within that triangle? Angle A. You have to, side drawer in my desk. You've got to remember that angle A is going to be 32 degrees. Why? What kind of angles are those from geometry? They are congruent, but do you remember what they're called? Anybody? A. Sounds like. Who? No. No. Mm-mm. Alternate who? Alternate interior angles. You're welcome. So we've got alternate interior angles. The same thing is going to be true about the 48-degree angle, right? Okay. Now, find it. It's fine. Okay. We've got to find B. Do I have enough information to solve for side B? Well, sure you do. What can I, do I have anything to tie together right now? You know how I always take an angle and its opposite side? Do I have anything that I can tie together the way I have the picture right now? I've just got to find the other angle. How am I going to do that? 180, take away 32, take away 48, 70, 80, 100. So now I'm going to take 100 and 5 and I'm going to tie them together. Okay?
But why is it like that line and then
Because those are angles of depression.
so is it always going to just be like straight down?
These are alternate interior angles. And from geometry, you should know that alternate interior angles are congruent. Or even if you didn't know that what the name of them is, because as you can hear, y'all are like, adjacent, interior. Oh, you can't remember what they're called, but you knew Easter was like, they're congruent. You knew immediately that they were congruent. And remember, I know when I taught it, I said, look for the zigzag, because you'll go here and then here. Remember the zigzag we looked at? But they are alternate interior angles. You got to remember that, okay? And if you didn't up till today, you will from now on, okay? Yes? From 90? Okay, you dropped a perpendicular straight down and did it that way. Because you added this little piece on the left and this little piece on the right, correct? Okay, now, can you just randomly choose 90? No. You lucked out and you got it right because in order to get 100, you would have got, what was this little piece right here you had, Christian? 32 from 90 is 58. This was 58, and then you knew that this was 42, right? And then you added them together to get 100. That's what you did, and you lucked out this time, okay? If you drew that perpendicular, you can do that. But here, another way you could have that 100-degree angle, folks, is by going, aren't these supplementary angles right here? Tyler, you said complementary, supplementary. Don't they form? Well, got to kind of stretch our imagination a little bit. Aren't they kind of sort of like a linear pair, but three of them? The rainbow, remember? So we're drawing on a lot of stuff. Can you tell there is a lot of geometry and trigonometry? There's a bunch of stuff that you have to know. Now, okay, we got 100. We got 5. Let's get back to law of sines. We've got 100 and 5 tied together. So that means sine of 100 over 5, this is part A, over sine of who? 48 over side B. Remember that distance from the plane to milepost A. And then we just cross multiply, folks. Sine of 100 times B is equal to 5 times sine of 48. Morgan, did you have it set up that way? Okay. Are you a parentheses ninja? Okay. All right, I need somebody to just sit at my desk and take notes today. Okay, yeah.
How do you know which one to use to put underneath?
The opposite side. You choose the angle and its opposite side.
Wouldn't the opposite side for that one be C?
No, it said it needed the distance from the plane to most. That's okay. That's all right. Okay. I got you. Okay, thank you. Tiffany, are you good with that? It's the angle and its opposite side. Now, here we go. Oh, thank you. All right, so calculator-wise, parentheses ninja, 5 times, parentheses sine 48, close, close. I get my product, and then I divide by sine of 100. And I get approximately 3.7, 3.8 if I round to the nearest 10. 3.8, and it has to be in miles. We're talking word problem, so it needs to be in word problem form, okay? Wow, that's just kind of crazy. That's almost 4 miles in the air, y'all. That's crazy. Crazy to me. All right, and then B. What does B say? B says, find the elevation of the plane. Well, what's that mean? Elevation of the plane. A B with a circle around it. It's part B. It's just a B with a circle around it. I didn't disconnect the B from the circle, sorry. All right. How do you find elevation? What's the elevation? You drop the altitude. It is exactly how far from the ground the airplane is, okay? So when you're looking at this, now is what I want to do, what Christian was doing earlier. Okay, I've got to drop that altitude for this picture. Now, boom. I've got to find X. Now, folks, we are living now for part B in the land of what kind of a triangle? A right triangle. Do I have to use law of sines? No. Go back and use some old horse caught a horse taking oats away. That's it. If I've got the B, I just solved it to be 3.8, didn't I? So I'm counting on it being correct. As long as it is, I can say, okay, I got to find X. Well, here we go with the geometry again. I could have used this, but I didn't have this side. And I can't say that this is going to be split in half. I can't say that this piece here is going to be 2.5 and over here is going to be 2.5 because I don't know for certain that this altitude is going to bisect that segment AB. Okay? So I'm using what I have at my disposal. Right now, I have the distance from the plane to milepost A, which I found to be 3.8 miles. Okay? And I know that this angle is 32 degrees. So now I'm going into right triangle trig, and I label my triangle. This is the some old horse caught a horse taking oats away. Label my triangle. This is my opposite side. This is my hypotenuse. What trig ratio uses the opposite and the hypotenuse? Some old horse. So it is sine. Some old horse. So I'm going to have sine of 32 divided by 1 because I set it up as a proportion. And then opposite over hypotenuse, which is x over 3.8. Okay? This is a test, and I am going to win. If you're, no, you're not. Is there a piece of paper on the thing, Zach? There's not a piece of paper on my laptop, is it? Okay, all right, I'm just trying to figure out what's going on. 1 times x cross multiply is x, and then sine of 32 times 3.8, again with the calculator. Here we go. Hey, what's up? Walking around, eating peaches. Well, okay. Now it's on recording that Mr. Helms is killing time.
Nobody watches them anyway.
Shut up! I had 2,000 views. Shh, they're testing. Shh. It's on. It's on now, brother. Hey, no strawberries for you.
Strawberries?
Yeah, man. I had supper tonight. You don't get any strawberries. None. They don't. Oh no. Nope. You better. Here we. Here we go. 32.3.8, which is approximately 2.0 miles. Okay? Question? No questions at all? Got it? Okay? Questions at all? Here's the thing, folks. You need to, like what y'all just did, and that's so soothing. No, I am thinking only of this material. Nothing else is rambling through my noggin right now. Nothing. Well, hot dog. Every Harlem Shake gets over 2,000 views. Just saying. I got it. Just leave it there. Okay. Today we're going to go over, folks, I'm going to give you a bunch of examples, 3. That's it. Seriously, that's all. Maybe not. First block had a lot of time left at the end of class to work on homework, and that's what I want to happen. No. This can be so detailed and so lengthy, like you're going to have 4 problems, I think. Yeah, you're going to have 4 problems. But 2 of those problems could be 2 extra problems. No, not 30-minute problems. Here we go. That ambiguous case, folks, is that side-side angle that we never could talk about in geometry that we can talk about now in trig because we're older, we're wiser. We're talking about the donkey postulate. We've got 3 cases that we're going to look at, okay? Yesterday, we had angle, angle, side, and angle, side, angle. And today, we're going to look at the cases, what happens when we finally have that side-side angle thing occur. We've got 3 cases that can occur. The first one, this is the one that everybody wants to solve. The answer will be no, triangle exists. You want to get it to a point and go, yes, I don't have to do anything else but write, no, triangle exists. And there is a case where this will happen, okay? What this is going to look like, pardon me? Yeah, of course. How does no triangle exist? Well, you think about it, if you had an angle and a side given that doesn't match, meaning doesn't match, they don't meet, okay? Like one side is too short to meet the other side. Then I can't form a triangle to have one exist. So that's what it's looking like, okay? The second case, you'll see what mathematically that looks like. The second case is one triangle. Only one triangle exists. What's going to happen is you're going to work. The work is the same. You're going to find the angle, find the side opposite, tie them together, set up the ratio, cross multiply, and solve. The process is the same, but when does only one triangle exist? It only exists when we have this right here. Now think back to geometry. Think back to triangle congruence. Remember, side, 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 angle, 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 side, and there was one other one. Now, you guys, some people would do it just for ha, giggles. But you would look at this, and you would look at another triangle, and you would go, oh, well, that's side, side angle. No, it's not. Do you remember what we had to put? If you had 2 triangles marked up this way, it looks like, because all right angles are congruent, right? It looks like we would have an angle and a side and a side. But you know that we would have gone slam crazy if you'd have written that on your paper. And some of you did. You put SSA. But the 2 triangles would not be congruent by side-side angle. How would they be congruent? Do you remember what that other option was? It was side, 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 angle, 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 side, and what? Right triangle congruency, you're warm. You're in the right room. Side, 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 angle, angle, side, and there was one more that had only to do with right triangles. Nope. What is this side called in a hypotenuse leg? Who taught you geometry? Atta boy. It's the hypotenuse leg theorem, folks. And we would always, if you put side, side angle, well, I'd count it wrong and go, really? Seriously? You're going to write that on your paper? But this goes back to geometry again. When we are working law of sines and we have only one triangle exist, it has to do with this right triangle. It's going to be a right triangle. That's the only triangle that can exist. When you have that case where you only find that one's going to work, it ends up being a right triangle. Ooh, I'm so totally seeing a test question out of this. Now, I don't know what is going on with this thing, but I'm by it. Third case, and this is the case that you only want to have to do one time, okay? If you have no triangle exists, you have one triangle exists, then we're going to have, what do you think? Two triangles exist. Two triangles exist. In fact, you're going to have two solutions. You're actually going to have two triangles. You're going to have your original, which is your normal triangle that we already know how to solve. And then we're going to have this triangle, and I'm calling it, you won't find this in the book, the supplement triangle. Now, Tyler, you've already kind of said complementary, supplementary. What does supplement mean? Y'all remember what number is tied to that word? 180. Very good. Supplement has to do with supplementary angles, okay? If I were to tell you, hey, here's a 30-degree angle, what's the measure of its supplement? 150. How'd you get that? You subtracted 180 minus 30, and you found its supplement to be 150. That's kind of what we're going to do here, okay? Now, I'll just tell you, when you label your triangle, when you label, oh my, mercy me, mercy. When you label your triangle and realize you have side-side angle, proceed with caution. Okay. You can make this very difficult, or you can be patient and be okay with things. Okay? My suggestion is be patient with things and just do the work. Okay? It's not difficult at all. It really is not difficult at all. So we're going to proceed with caution because you know every problem we do today is going to be what? Either no triangle exists, one triangle exists, or two triangles. You know it's going to happen. And guess how many examples of each you're going to have? One of each. Okay? Doesn't take rocket science. Hey, get your unit circle out. I want you to look at your unit circle just for a second. You can look at it. You can think about it. Think about your unit circle, folks. I want you to answer this question for me. Yep. Well, you don't have to write that, but I do want you to write the next sentence. Between what two numbers does the sine value fall on the unit circle? You're going to put a number in those blanks. I want you, between what two numbers does the sine value fall on the unit circle? I want you to look at it. Think about it. You don't have to write this because you already I'm going to put the first ones. Well, the first terminal points we learned were 1, 0, 0, 1, negative 1, 0, and 0, negative 1. You guys agree with that? Okay. Which value is the sign value in our ordered pairs? It's the Y value. So, hey, Zach, if you will, because you have to do it with the mouse, I can't do it up here. I want you to highlight all of these Y values. Just the Y values. There we go. And this is what you need to do on your paper too. With a pen or highlighter or markers back there. Because I want you to notice something, okay? What's the lowest value of sign on this unit circle? Negative 1. What's the highest value of sign? 1. Okay? This is important to us because this is going to help you in the long run. Okay? Notice that we're using the law of signs, right? So if we're using the law of signs, that means that everything having to do with sign is important to me in solving these problems. If you find a sign value outside of these boundaries, this negative 1 to positive 1, then what do you think is going to happen? Anybody have any guesses? There's not going to be a triangle at all. Then no triangle will exist. Some of you, and you better put stars, rainbows, and ponies by that. Some of you are good big picture people, and that you will think of this, you will lock into this, and you will remember this. There are those of us who get caught up in the math, and we will figure it out once we see something in our calculator. But if you have a sign value, sign of an angle, that is outside of that negative 1 to 1 boundary, then all I have to do, I can stop working and write, no triangle exists. Now, how many of those problems do we want to see? On a quiz of 10, 9. I'll give you 9. Just give me 9 of them. I'll do one more that's only one triangle, right? Watch how this comes about being. Hang tight. Giving you some background information first. Here we go. Here's the way the problem might look. You might be told to solve the triangle, and you are given a picture, okay? We're given our good old triangle ABC. That's a C. You're given an angle of 30 degrees, a side of 16, and a side of 7, okay? I want you to look at that. You need to get into a habit of marking up your triangle, okay? You need to look at it and go, okay, I got an angle, I got a side, I got a side. Yep, this is side angle. Ooh, I better hold on. Okay, something's getting ready to happen, right? This is when, like if it were a flow chart and you realize it's side angle, then we've got 3 options. No triangle exists, only one triangle exists, 2 triangles exist, right? So we've got 3 options that could occur. The solving's the same as always. If we're solving the triangle, then we're going to solve for all of the missing sides, all of the missing angles, correct? Do I have anything that I can tie together? Do I have an angle given with its opposite side given? A and 7, right? All right, so let's tie them together. Angle A and our 7 tie them together. We know that it's going to set up our ratio. This is the one we're going to use for everything. All right, so we've got sine of 30 over who? Which is equal to, what is this forcing us into finding? Sine of who? Sine of who? Sine of C, very good, because that means we're going to have to find angle C over what's its corresponding opposite side? 16. It's forcing us to find that angle first. Now this is different from yesterday, because yesterday all we found were side measures, right? When we're dealing with the sine. Cross multiply and see what's going to happen. And for this problem, for every problem today, you need to show all your work, okay? What am I solving for? Am I solving for sine of C, or do I want to know that angle measure? How are we going to get C by itself? Say it again. Divide by 7. All right, so let's do that. We're going to divide by plain old 7. I want you to look what's going to end up happening. I'm going to have not plain old C, but I'm going to have, this is the moment that I'm getting ready to give Miss Wallace a noogie through the wall, y'all. Okay. I think y'all should be very proud of me right now. Why? Because I'm using self-control. I'm so using self-control. Here we go. Sine of 30. Let's put this in our calculator. Might as well laugh as cry, right? Sine of 30 times 16. Find that product, and then we're going to divide by 7. Now, look what's happening. We get the sine of C is equal to 1.1428 blah, 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 right? But just put the 1428 dot, 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 okay? Now, I want you to look at it. How am I going to find angle C? Do I want to divide? I can't divide by sine. Do that -1 thing. We've got to take the inverse sine. So I'm going to switch this around, okay? And I'm going to write inverse sine, well, angle C is equal to inverse sine of 1.1428, blah, blah, blah. And I'm going to show you how to put this in the calculator, okay? Here we go. Instead of putting that whole number in again, you guys know how to use the answer button, right? So you're going to have second sign, second negative symbol, which is the answer. If you look at the negative sign, if you look right above, it will give you the last answer in your calculator. And I want to hit enter. Shut up. Oh! Do you see how you get caught up? Cross, multiply, divide, punch in the calculator. Do you see what happens? Now, did anybody, and I want you to be honest, did anybody at any point look at 1.1428 and go, no, it's out of our boundaries? Seriously? You did? You did? Okay, and you just let me proceed with caution? It's higher than 1. But you knew I was going to make my point, right? Okay? See, you know why they notice that? Because what are they? Are they forests or trees? They're forest people, okay? They see the big picture. I am a what? I am tree hugging. I am on that tree like it's right here because I get caught up in the math, okay? I get caught up in it. But when I see this, how many of us are going to go, oh, my God, I put something in my calculator wrong. Let me go back through. And you're going to go back through it. I'm going to, and some of y'all will too. Okay. So, yeah, right? So look at what we're going to do. What do? We get Write that down. What did it say? Domain. We're going to write it down because you need to know what you're going to see in your calculator. When you see domain. Say what? All right, hold that thought. This 3 triangle dot thing means therefore no triangle exists. All right, now, Damien, let me show you what I'm going to do again on the calculator. Here we go. I had sine of 30 times 16. And I'm dividing by 7. And it gave me 1.1428, la, 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 right? I know that I need to take the inverse sign of that answer. So I hit second negative symbol. And then I hit enter. And I get which means what? No triangle exists. How? You want 10 of those on a 10-question quiz, don't you? Yep, bring it on. Would you show all your work? Nope, fart faces. That's why you're getting a 3 question with all of them with 2 triangles exist. No, that's a lie. You won't have that. Maybe. Make me mad, you will. No, I'm just kidding. All right, here we go. Questions on this. Because when we're finding, who said that? When you're finding angle measures, you can't use just straight up sine. You have to use the inverse sine or the inverse cosine because we're finding that -1 thing. When we're finding that, the only way I can move that sign is to take the inverse operation, which is inverse sine. Okay?
So when you're finding what?
The angle measure, C, then I have to find the inverse sine. Or, well, yeah, it's always going to be inverse sine with law of sines. Okay? Now, I need you to put just because. Just for this problem. Why? You're not ever going to have to do this again, but for your notes, I need this to be in your notes. Okay? Why is it no triangle exists? Because our sine value of 1.1428 blah, 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 blah is outside of the -1 to 1 range. Boundaries, whatever you want to put. I just need that to be in your notes, okay? Just humor me. You need it to be there because you need to understand why there's an error, okay? No, I just found I hit second sign, and then I took the inverse sign of that answer, that 1.1428, la, 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 and then I hit enter. I'm just taking the inverse sign of that value, okay? Or I'm trying to at least. Now, we okay with no triangle exists? All right, let's move on. Now, we're going to do the 2-case scenario. We're going to jump to that. We're going to do the easiest thing we can do to the most difficult and time-consuming thing we can do. Okay, example 2. Here we go. Another way you might see the problem given is just to be given this information. Little a equals 10. Little b equals 16. Angle A equals 30 degrees. And you may be told to solve the triangle. Okay, now, my good old triangle ABC. It's just what it is. It could be anything. Be sure you label your triangle correctly. Side A is 10. Side B is 16. Angle A is 30 degrees. And as soon as you get the information on your triangle, you need to mark it up.
Will it always be like A, B, C, going like that?
You can label your triangle however. I just tend to do the same thing every time. Yep. All right, so we've got an angle. I've got a side. I got a side. Side, side angle. Proceed with caution. And you already know what this is going to be. You already know this is going to be that 2 triangle scenario, okay? So what can I tie together? The angle 30 degrees tied together with the 10. Do you guys agree with that? Okay, so let's talk about original triangle. The original triangle. Folks, this is just like we've always done, okay? We're doing the same thing. Sine of 30 over who? 10. And because of the information given, it's forcing us to find which angle first. Sine of B over who? 16. Okay? And now we've got to cross multiply. So I've got sine of 30 times 16 is equal to sine 10 times sine of B. And then mathematically, what are we going to do? We're going to divide by 10. And I'm going to rewrite this. I'm going to swap sides on you, okay? And I'm going to put sine of B is equal to, calculator. Zach, thank you. All right, so we've got sine of 30 times 16 is 8 divided by 10. So I've got 0.8. Sine of B is equal to 0.8. Do you guys agree with that? And am I safe with that boundary, with that number? Does it fall within my negative 1 to 1? Yes, I'm safe. How do I find B? Inverse sine. Inverse sine of 0.8. That one's easy. Got 53.1? Yeah? Facile? All right, now, we have, I want you to go and I want you to put it in the original triangle, 53.1, which is angle B. 53.1 degrees. Cloud. Because this is a side-side angle, I have to test the supplement, okay? So, test the supplement. Here we go. The supplement of what? I'm going to take 180, and I'm going to subtract the angle I just found, minus 53.1, and we're going to have a new angle B, which is what value? What's 180 minus 53.1? 126.9. Okay. We have a new angle B. Let's see if it's going to work. Draw you another triangle. All of the original information goes 30 degrees, 16. What was that other one? 10. But now I'm going to take 126.9 and I'm going to test to see if that angle is acceptable within our new supplement triangle. Okay? Now, the way I test it is I say, okay, well, can I find the third angle? So I come over here and I say 180 minus 126.9 minus 30. What's the difference? What am I left with? Say it again. 23.1. That means that I have acceptable angle measures in my supplement triangle. If I can get them to all three total 180 degrees, then I'm good to go. And then, folks, we solve them triangle like normal, okay? Because, why do I have to test it? I have to test it because it goes back to something we just got finished going over. You were tested on it last week. What are the angles? What are they called? For example, a 30-degree angle. See it in your mind's eye, okay? Give me another angle measure that is at the same place. It terminates at the same place as 30 degrees. Think. You can rotate positive, you can rotate negative, but I want another angle that is the same place as 30 degrees. 390, atta girl. How'd you get 390? To 30, and you got 390. So you're saying that 30 degrees and 390 degrees are both the end at the same place, right? What are those angles called? Coterminal angles. That's why we have to test this supplement. It all goes back to coterminal angles. Okay? Good question. I'm seeing a question on your test in your future. I'm just saying. Okay? Might would write that in the margin somewhere. It all goes back to coterminal angles. Okay? That's why you have to create this supplement triangle. Now, I have to put that to the side for just a moment, and I've got to go back to my original. You can do whatever you want to do. You can finish solving that supplement triangle, and that's fine. But me, I want to go from beginning to end, so I'm going to go back to my original triangle, and I'm going to solve everything that I possibly can in my original triangle, okay? And here it is. Here's my original. Doesn't matter, but I choose to go back to the original and then go back to the end. I don't care. If I were to finish this one out, then what would I do? I'd forget to go back and do this one. So that's why I'm going to go back to the beginning and start and go to the end. So the next thing that I would find would be angle C. Because I've got two of my angles given. So in order for me to find angle C, I'm going to take 180, take away 53.1, take away 30, isn't it? And what am I given for the original triangle? 96.9. Y'all double check me now. Yeah? So I've got angle C is 96.9. I'm going to go put it in my picture. And now do I have enough information for me to find that missing side? Yes. All right, I'm going to use the original ratio, sine 30 over 10. I've got to find that missing side. So what am I forced to use? Sine of 96.9 over C. Okay? Cross multiply, do the same thing we've been doing. Sine 30 times C is equal to 10 times sine of 96.9. Do the math. All right, so we got 19.9 for that side. I'm going to go back and put it in my picture. Visibly, when these stupid little clouds, I know the clouds are getting on some of y'all's nerves. That's all right. But I can see what I have left to solve for. So that's why I like them. Go back to your supplement triangle now. We've got to finish everything in that supplement. We're almost done. We only have to find what? We only have to find one side. So you still use your original ratio that we tied together from the get-go. Yes. On the cases? Oh, when you test that supplement. If you can get, when you do that new angle B, yeah, unless it's a no triangle exists. And you will know immediately, when we do the next example, you know immediately when you try to test that second triangle and you're like, oh, hold up, no. Boom, you're done. It may you may end up with a negative number. You may end up with like you may be given an obtuse angle already within your original triangle, and your new angle B could be another obtuse angle, and you know that's not possible because your triangle can only total how much? 180 degrees. In the next example, you'll know immediately how come this is the only time it works. Okay? Yes? Yep. that good? Sine of 30 over 10 equal to sine of who? 23.1 over side C. And we do the same thing. Sine of 30 times C is equal to 10 times sine of 23.1. Folks, solve for C for me, please. You don't need me to. What do you end up with that supplement triangle side C? 7.8. And then I want to put that in my picture. So now everything's got a value. All of the angles are filled in. All of the sides are filled in. I'm good to go. The answers are the clouds, yes. And you know what I'll probably do? Anytime I give you a worksheet, I'll have blanks. So you'll know where to put your answers, and I don't have to look for clouds. If I don't want to, if you don't like drawing clouds. Okay? Questions at all? We got one more. We're done with this one. We got one more example. Let me ask you something. Questions at all? That's all right. You can do that because you're going to do the same thing over and over again. Here we go. Last one. Solve triangle ABC if angle A is 107 degrees, side A is 17.2, and side C is 12.2. Our good old triangle ABC. Fill in the information. Okay, same process all over again, so here we go. Sine of 107 over 17.2. And what are we kind of being forced into solve for? Angle C. So it's going to be sine of C over who? Right on. And then let's do the math. Sine of 107 times 12.2 equal to 17.2 times sine of C. Okay? Let's see. Folks, you know you can put all this in one line, right? But you have to be a parentheses ninja to do it. Sine of 107 times 122. Close that. I close that. I close my numerator divided by 17.2. And oh no, that ain't right. Let's go back. Sine of 107 times 12.2 divided by 17.2. Did y'all get 678.678? Okay. Is my value okay? Yeah. Now I've got to do what to find angle C? Inverse sine, all right? So 0.678. Remember, find the inverse sine of your answer. And we get that angle C is approximately 42.7. Yeah? Everybody cool with that? All right, what do we immediately have to try?
You only do it if it has like the dot, 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 the inverse sign.
No, you try it every time. I just don't want to write all those numbers down.
Every single time on every one you do.
No, not on every one you do if you're solving for an angle. Okay? All right, now, what do I have to do when I get 42.7? Check the supplement angle. Okay? So, supplement. Sup triangle. What is the supplement of 42.7? Sorry. 37.3. So, no. Okay, that's better. All right, now look. Morgan. Look. Put the original one in back. Put the original one back in there, 107. And now we've got this angle C. Look. All right, 42.7 in our original. Hallelujah. Yes, yes. It just transfers because it is our original information. The original information still has to go in the supplement triangle, but now we've got this new angle C. Hello? What? What? Can that be possible, y'all? Heck no. That can't be possible. No way. So, why can it not be possible? Because it's over how many degrees? It's over 180. Not bad. Not possible. So how many triangles exist? Only one triangle exists. Now, are we done? Now we got to solve for the rest of it. Now let's see what we got to solve for. Psh, easy. Angle B, that's the easiest thing to solve for. So it's going to be angle B, which is equal to 180 minus 42.7 minus 107, which is 30.3. Okay, sounds good to me. 30.3. Cloud. Oh, I can see immediately what I have to solve for. What do I have to solve for? Now I got to solve for side B. So I'm going to use which ratio again? The original one, which is what? Sine of 107 over 17.2, which is equal to sine of 30.3 over little b, right? Solve it. It's a race. 9.1. So I've got side B is approximately 9.1. Let me go back down there for any of you that are still copying or working. Okay. Here's your homework. Page 214. I want you to do 4, 5, 15, and 16. You need to get started on this right now. You are not going to pack up with time left over. No, no, no. You're not. You're going to work until the bell. Yes. And you're going to like it. Yes, that's right. Because you use each other now in case